Somewhere in the galaxy, a star that has burned for millions of years begins to fail. Its fuel exhausted, its core collapses inward with a speed that defies comprehension, and in the silence of space, gravity wins. The star folds into itself, smaller and smaller, until it vanishes from the visible universe and leaves behind only a whisper in the fabric of space-time. What remains is not an object in the traditional sense, not a sphere of matter or a ball of compressed light, but something closer to a question mark drawn in the dark. We call it a black hole, and for decades we have studied its edges, measured its pull, traced the orbits of stars that dance around it like moths around a candle they cannot see. But beyond the mathematics and the measurements, beyond the equations that describe its behavior, there lies a deeper mystery, one that feels less like a problem to be solved and more like a room we have never entered. This room does not sit in space the way a house sits on a hill. It does not have walls we can touch or a floor we can walk across. It exists in a dimension folded away from the rest of reality, a pocket carved out by gravity so intense that it bends the rules we thought were fixed. Light does not escape from this room. Time does not pass through it the way it passes through our lives, and yet the room is there, waiting, patient, indifferent to whether we understand it or not. Some imagine it as a trap, a cosmic dead end where matter goes to be erased. Others see it as a threshold, the entrance to something we have not yet learned to name. Both might be true, both might be too simple. The universe is full of doors we cannot open, horizons we cannot cross, questions we cannot answer with the tools we have today. But the black hole is different. It does not hide behind distance or time or the limits of our instruments. It sits in plain view, pulling at everything around it, shaping the light of entire galaxies, and still we cannot see inside. We stand at its edge and look inward, and the darkness looks back, not with hostility but with silence. It is the silence of a room that has no need to explain itself, a room that simply is, whether or not we ever find a way to step inside. In the chapters that follow, we will walk slowly around this room, tracing its outline, imagining its interior, listening for the echoes that might tell us what it holds. We will not solve its mystery, because the mystery is not meant to be solved, not yet, perhaps not ever, but we can wonder. We can picture the doorframe, the threshold, the strange geometry of a space where the laws of physics curve into something almost poetic. If you have ever stood at the edge of the ocean and felt the pull of the deep, if you have ever looked up at the stars and felt the weight of all that distance, then you already know the feeling we are chasing. If you find yourself drawn to this mystery, if you want to explore more stories where science meets wonder, stay with us as we step closer to the edge and let the darkness teach us what it knows. The black hole is not empty. It is not a void. It is a room, and every room, no matter how strange, has a story written in its walls. If you were to approach a black hole from a distance, drifting through the cold vacuum on a trajectory that would carry you closer and closer to its center, you would first notice the stars. They would begin to shift, their positions sliding across the sky in ways that defy the neat geometry of the cosmos you thought you understood. Light from distant galaxies would bend around the black hole's mass, curving like water around a stone, and the stars behind it would appear in strange arcs and rings, as if the universe itself were being stretched across an invisible lens. This is the black hole's announcement, the way it changes the space around it without ever revealing itself directly. You would not see the black hole, not at first. You would see only its effects, the way a river announces itself by the sound of its current long before you reach its banks. As you drift closer, the bending grows more severe. Stars that should be behind you now appear ahead. Light that should have passed you by hours ago circles back, looping through the curved space like a message that cannot find its destination. And then slowly you begin to perceive the edge. It does not look like a wall or a surface. It does not shimmer or glow or mark itself with any kind of boundary. It is simply the place where light stops climbing outward and begins to fall. We call it the event horizon, and the name is more poetic than it sounds. An event is something that happens. A horizon is the line where the visible world ends. The event horizon is the line where events end their relationship with the outside universe, where what happens next can no longer send news back to the rest of us. Imagine standing on a beach where the tide is always coming in. You take a step forward into the shallow water, and the waves pull at your ankles, but you can still step back if you choose. You take another step, and the pull is stronger, but you are still in control. Another step, and the water is at your knees, and you have to lean against the current to stay upright. One more step, and suddenly the ground beneath you drops away, and the current is no longer something you resist, but something that carries you. And there is no stepping back, no reaching for the shore, because the shore is already impossibly far, and the water has decided your direction. The event horizon is that step, the one where the choice to return is taken from you not by force, but by geometry. Space itself has curved so sharply that every path forward, every direction you might try to move, leads inward. Outward has ceased to be a direction that exists. But here is the strange part, the part that makes the black hole feel less like a trap and more like a riddle. If you were the one crossing that line, you would not feel it. There would be no jolt, no sensation of passing through a barrier, no moment when the universe clicks and changes key. You would simply continue falling, the stars still wheeling around you, the darkness still deepening, and you would not know that you had crossed the threshold until you tried to look back and realized that back no longer means what it used to mean. For you, the event horizon is not a wall. It is a moment, a point in your journey where the future becomes the only direction, and the past becomes a place you can see but never touch. For those of us watching from the outside, however, the story is different. We would see you approach the horizon, and we would see you slow. Not because you had changed your speed, but because the light carrying your image to us would take longer and longer to escape the black hole's pull. You would appear to freeze, your motion asymptotically approaching stillness, your light redshifting into deeper and deeper hues until you faded from view entirely, not because you had vanished, but because the photons reflecting off your body could no longer climb out of the gravitational well. In our frame of reference, you would hover forever at the edge, a ghost image locked in time, while in your own frame you would have already crossed, already begun the descent into the room that has no exit. This is the doorframe of the cosmic room, the place where two stories diverge and never reconcile. Outside the event horizon, the universe continues its patient expansion, stars burning and dying, galaxies drifting apart, time marching forward with the steady inevitability we have always known. Inside the event horizon, time becomes something else, something more like space, and space becomes something more like fate. The room inside begins here, at this edge that is not an edge, at this boundary that exists only in the relationship between the falling and the watching. It is the threshold where the universe folds a corner of itself away, where the rules we thought were universal reveal themselves to be local, contingent, negotiable. Some have tried to describe the event horizon as a point of no return, and the phrase is accurate but incomplete. It suggests a loss, a crossing into danger, a mistake that cannot be undone. But the event horizon does not care about our fear. It is not a warning. It is simply the shape that space takes when mass collapses beyond a certain density, when gravity becomes so concentrated that it carves a pocket into the fabric of reality. The room inside is not malicious. It does not hunger. It does not wait with intent. It simply is, and the boundary that defines it is as natural as the curve of a river or the slope of a hill. We stand on the outside and call it a horizon because we cannot see beyond it, because our light and our signals and our stories stop there. But the room continues, indifferent to our ignorance, patient in its geometry, a space that exists whether or not we ever learn to map it. And so we linger here at the edge that isn't an edge, tracing the line where the universe says goodbye to itself. We cannot cross it and return. We cannot send probes inside and wait for their data. We can only imagine, calculate, and wonder. The event horizon is the door, and the door is open, but it opens only one way, and what lies beyond is not darkness in the absence of light, but darkness as a place, a room with its own rules, its own time, its own quiet architecture. To understand the black hole, we must first understand this threshold, this place where the journey inward begins and the journey outward ends. We must learn to see the event horizon not as a wall but as a translation, a shift from one kind of existence to another, and accept that some translations cannot be reversed. The room is waiting, the door is always open, and the edge, for all its strangeness, is only the beginning. Time, as we experience it, is a river that flows in one direction. We are born, we grow, we age, we remember yesterday and anticipate tomorrow, and the current carries us forward with a constancy so reliable that we build our entire understanding of cause and effect upon it. Events happen in sequence. Causes precede effects. The past is fixed, the future is open, and the present is the narrow bridge we walk between them. This is the time we know, the time that governs our lives, and it feels as fundamental as gravity or light, as though the universe could not function without it. But near a black hole, time begins to soften. It stretches, it bends, and at the event horizon it does something that feels almost like stopping, though stopping is not quite the right word. Imagine you are watching a friend fall toward the event horizon. You are stationed far away, in a safe orbit, your instruments trained on their descent. At first, everything seems normal. They accelerate under the black hole's pull, their velocity increasing, their trajectory smooth and predictable. But as they approach the horizon, something strange begins to happen. Their motion slows, not from their perspective, but from yours. The signals they send back to you, the light reflecting off their suit, the radio transmissions marking their position, all of these begin to arrive with longer and longer intervals between them. Time itself, as measured by the photons traveling from them to you, is stretching. They appear to slow, to drift, to approach the horizon in a motion that grows asymptotically gradual, and eventually they seem to stop altogether, frozen at the threshold, their image locked in place like a photograph that never finishes developing. But your friend does not feel this slowing. In their own frame of reference, time continues to pass at the same rate it always has. Their heartbeat does not slow. Their thoughts do not drag. They cross the event horizon in a finite amount of their own time, perhaps a few seconds or minutes depending on the black hole's size, and they continue falling inward, unaware that to you, they have become a still image smeared across the horizon. This is the fundamental asymmetry of time near a black hole, the way it fractures into multiple perspectives that can never be reconciled. You see them stop. They experience themselves continuing. Both stories are true, both are complete. But they are no longer the same story. This stretching of time is not an illusion or a trick of perception. It is a consequence of the way gravity warps spacetime, the four-dimensional fabric that weaves together space and time into a single continuum. Near a massive object, spacetime curves, and the curvature affects not just the paths that objects take through space, but the rate at which they move through time. Clocks closer to the black hole tick more slowly than clocks farther away, and the difference is not metaphorical. It is measurable, predictable, and absolute. If you could somehow hover just outside the event horizon for an hour and then return to your distant orbit, you might find that years or decades had passed for those who stayed behind. Time dilation near a black hole is so extreme that the event horizon becomes not just a spatial boundary, but a temporal one, a place where time, as experienced from the outside, stretches toward infinity. Inside the event horizon, the relationship between space and time undergoes an even more profound transformation. The inward direction, which was once a choice, a direction in space that you could move toward or away from, becomes as inevitable as the forward direction in time. You cannot stop falling inward any more than you can stop moving forward through time in ordinary space. The singularity at the center of the black hole, the point where all the mass has collapsed to infinite density, is no longer a place in space, but a moment in your future, an event you will reach not by traveling but by waiting. This is what it means for time to bend so far that it becomes indistinguishable from space. The room inside the black hole is not just a spatial room. It is a temporal room, a pocket of moments arranged in a geometry we have no language for. Some imagine this as a kind of trap, a place where time stops and everything freezes in an eternal present. But this is not quite right. Time does not stop inside the event horizon. It changes direction. It ceases to be the dimension that carries you forward and becomes the dimension that carries you inward. The future is no longer spread out ahead of you in a range of possibilities. It is focused, concentrated, aimed at the singularity with the precision of a countdown. And the past, the outside universe you left behind, recedes not into memory but into a kind of unreachable distance, a place that still exists but can no longer touch you. You are falling through time as much as through space, and the room around you is as much a sequence of moments as it is a volume of space. There is something almost serene about this, if you can set aside the fear. To fall through the event horizon is to surrender control, to stop fighting against the current and let the geometry of the universe carry you where it will. There is no decision to make, no path to choose. The room inside the black hole does not offer you options. It offers you inevitability, and there is a strange peace in that, the peace of knowing that the next moment will arrive whether you will it or not, that the future is already written in the curvature of space-time, and all you can do is watch it unfold. Outside the black hole, we live in a world of contingency, where every choice branches into new possibilities, where the future is uncertain and the past is solid. Inside the event horizon, contingency collapses. There is one path, one future, one destination, and time carries you toward it with the patience of a river that has always known where it is going. And yet, even as time stretches and bends and transforms into something unfamiliar, it does not disappear. The traveler falling inward still experiences duration, still moves from one moment to the next, still carries with them the memory of what came before. Time, even in its strangest form, remains a dimension, a way of ordering events, a thread that connects cause to effect. The room inside the black hole is not timeless. It is a place where time has learned to sit still from one perspective and to rush forward from another, where the river of moments splits into tributaries that never converge. It is a room where clocks disagree, where stories diverge, where the universe demonstrates that time, like space, is not as fixed as we once believed. Perhaps this is the most unsettling lesson of the black hole, the realization that time is negotiable, that the steady forward march we rely upon is only one version of a more flexible reality. Near the event horizon, time becomes relative, personal, fractured, and the room inside exists in a temporality that does not match our own. We cannot visit that room and return to tell the story, because the time we would spend inside is not the same time we left behind. The room is patient, it does not hurry, it does not wait, it simply exists in its own unfolding, a sequence of moments that belong only to itself. Gravity is often described as a force, a pull between masses, an invisible hand that reaches across the void and draws objects together. But near a black hole, gravity reveals itself to be something more subtle, more architectural. It is not a force in the way a rope pulls or a hand pushes. It is the shape of space itself, the curvature that tells objects how to move, the geometry that arranges paths and trajectories without ever touching them. Inside a black hole, gravity does not shout, it does not strain. It simply designs the room in such a way that every path leads inward, every direction curves toward the center, and the architecture of space itself becomes the walls, the floor, the ceiling, the corridors that narrow and spiral and fold into a center we cannot see. Imagine a building where every hallway slopes gently downward. You enter through the front door and begin to walk, and at first, the incline is so subtle that you barely notice it. You might think you are walking on level ground, choosing your direction freely, turning left or right as you please. But after a few minutes, you realize that no matter which turn you take, you are always descending. Every corridor, no matter how it curves or branches, leads downward. Every staircase goes down, never up. The building is not forcing you to descend. It is simply shaped in such a way that descent is the only option, and you move through it not because you are compelled, but because the geometry leaves no alternative. This is how gravity works inside the event horizon, a quiet architecture that guides without pushing, that shapes the possible without exerting visible effort. The curvature of space near a black hole is so extreme that it folds the fabric of reality into something almost spiral, a whirlpool where the paths of light and matter circle inward with an inevitability that feels both gentle and absolute. Photons, the particles of light that usually travel in straight lines, begin to curve. Near the event horizon, some of them are captured into orbits, circling the black hole in a thin shell just outside the point of no return, trapped in a kind of photon sphere where they loop endlessly, neither escaping nor falling. These are the ghosts of light, the echoes of stars and galaxies that came too close, and they hum around the black hole like a memory it cannot let go. For objects with mass, the curvature is even more pronounced. A spacecraft approaching the event horizon would find that its forward direction, the direction it thought was straight, begins to curve inward. If the crew tried to fire their engines and steer away, they would find that away is no longer a direction that exists, not in the usual sense. They could point their nose toward the stars, throttle up to maximum thrust, and still they would fall inward because space itself is falling inward, and they are embedded in that space, moving with it, unable to step outside the geometry that contains them. This is not a failure of propulsion or navigation. It is the consequence of a room whose walls are made not of matter but of curvature, whose boundaries are not marked by surfaces but by the shape of possible paths. Inside the event horizon, the inward curvature becomes total. Every geodesic, every natural path through space-time leads toward the singularity. There are no outward paths, no sideways paths, no paths that circle or loop or double back. The room has one direction, and that direction is toward the center, and the architecture is so complete, so thoroughly designed, that escape is not forbidden. It is simply absent from the structure. The black hole does not need to hold you. It has built the room in such a way that leaving is not one of the options written into the floor plan. And yet, despite this inevitability, there is no sensation of falling in the traditional sense. In the ordinary experience of gravity, when you fall toward Earth, you feel weightless because you and the space around you are accelerating together. Near a black hole, the same principle applies. A traveler falling through the event horizon would feel no sudden jolt, no crushing force, no sensation of being pulled. They would simply continue in freefall, floating through the curved space, following the geodesic that the geometry prescribes. The architecture is so smooth that it does not announce itself with violence. It simply is, and you move through it as naturally as you move through time, unaware that the path you are on has been narrowed to a single option. Of course, as you fall deeper, the smoothness begins to fray. The tidal forces, the difference in gravitational pull between your head and your feet, begin to grow. This is the consequence of approaching a point of infinite curvature, a place where the architecture collapses into a singularity. The room narrows, the walls close in, the gentle spiral becomes a steep descent, and the forces that were once subtle become overwhelming. This is the part of the story we call spaghettification, though the term is too playful for the reality it describes. The traveler is stretched, pulled, elongated by the differential forces, and eventually the structure of their body, the integrity of atoms and molecules, begins to fail. The room does not relent. The architecture does not soften. It simply continues to curve deeper and deeper until the curvature itself becomes the dominant fact, the force that overrides all others. But before that final descent, before the tidal forces tear everything apart, there is a stretch of falling where the room feels almost gentle, where the geometry guides you inward with the calm patience of a river that has carved its bed over millennia. This is the black hole at its most serene, the place where gravity is not a crushing hand but a quiet arrangement of space, a design so thorough that it does not need to insist. The room inside the black hole is not a chamber of horrors. It is a chamber of geometry, a space where the laws of physics express themselves in the purest form, stripped of contingency, reduced to the elegant simplicity of curves and paths and inevitability. Perhaps this is what makes the black hole so compelling, the way it transforms violence into architecture, the way it takes the raw power of collapsing stars and arranges it into a structure that follows rules, that obeys equations, that can be described and predicted even if it cannot be visited. The room inside is not chaos. It is order, the order of a geometry so extreme that it feels like poetry, a space shaped by forces we can barely imagine, but which in the end creates something almost beautiful. Gravity does not need to raise its voice. It simply curves the floor, narrows the halls, and leads you inward, and the room it builds is as inevitable as it is strange. There is a speculation, quiet and persistent, that has followed the black hole through decades of theory and calculation. It is not proven. It may never be proven, but it lingers in the equations like a half-heard melody, a possibility that refuses to disappear no matter how many times it is examined. The idea is this: perhaps the room inside a black hole does not end at the singularity. Perhaps it opens into something else, some other space, some other time, a region of the universe or beyond the universe that we cannot access from here. Perhaps every black hole is not a tomb but a doorway, and the singularity at its center is not a point of destruction but a threshold, a place where one cosmos gives way to another. This idea is sometimes called a wormhole, though the term conjures images of tunnels and passages that may not capture the strangeness of what the mathematics suggests. In certain solutions to the equations of general relativity, a black hole can be connected to a white hole, a hypothetical region of spacetime where matter and energy emerge rather than disappear. If a black hole is a place where everything falls inward, a white hole would be a place where everything is expelled outward, and the connection between them would be a bridge, a passage through the fabric of spacetime that links two distant regions, or perhaps two entirely separate universes. The traveler falling through the event horizon would not be crushed at the singularity, but would pass through it, emerging somewhere else, someone else, in a room that opens into skies we have never seen. It is a beautiful idea, and it has the texture of a story we want to believe. But the mathematics that allows for this possibility also comes with caveats, conditions, fragilities. The wormhole solutions require the black hole to be eternal, unchanging, free from the messy realities of rotating matter and collapsing stars. They require a kind of symmetry that the universe, in its turbulent unfolding, rarely provides. And even if such a passage existed, it might not be traversable. The throat of the wormhole, the narrow bridge connecting the black hole to the white hole, might collapse before anything could pass through. It might be filled with such intense curvature and tidal forces that any object attempting the crossing would be torn apart long before reaching the other side. The doorway might exist, but it might be a doorway that nothing can walk through. Still, the idea persists because it speaks to something deeper than mathematics. It speaks to the hope that endings are not final, that the universe is not a machine of irreversible loss, that the room inside the black hole might be the first room in a larger house we have not yet explored. Some imagine that every black hole births a new universe, a baby cosmos that inflates and expands in a space disconnected from our own. In this vision, the singularity is not a point of destruction, but a seed, a place where the collapse of one reality provides the initial conditions for another. The matter that falls into the black hole does not vanish. It becomes the substance of a new spacetime, and the black hole is the umbilical connecting one universe to its offspring. This is speculation, and it must be labeled as such, but it is speculation rooted in the recognition that the universe is stranger and more interconnected than we once believed. Black holes are not isolated pockets. They are woven into the structure of spacetime, linked by their gravity to everything around them, and the idea that they might also be linked to regions we cannot see is not as far-fetched as it sounds. The room inside might not be a dead end. It might be a junction, a crossroads, a place where the map of reality branches into paths we have not charted. There is also the question of information, a question that has troubled physicists for decades. When matter falls into a black hole, it carries with it information, the precise quantum state of every particle, the detailed history of every atom. According to the laws of quantum mechanics, information cannot be destroyed. It can be scrambled, hidden, transformed, but it must persist somewhere, encoded in some form. And yet, when matter crosses the event horizon, the information seems to disappear from the universe, locked away in a room we cannot access. This is the black hole information paradox, and it has led to some of the most intense debates in theoretical physics. One proposed resolution is that the information is not lost, but is somehow encoded on the event horizon itself, smeared across the surface in a pattern so subtle that we have not yet learned to read it. The horizon becomes a kind of hologram, a two-dimensional record of the three-dimensional matter that fell through it, and the room inside is not separate from the surface, but is, in some sense, contained within it. This is the holographic principle, and it suggests that the black hole is not just a room but a library, a place where every story, every particle, every bit of information is preserved in a form we do not yet understand. Another possibility is that the information is released slowly over the lifetime of the black hole through a process called Hawking radiation. Quantum effects near the event horizon allow pairs of particles to be created from the vacuum, and occasionally one of the pair falls into the black hole while the other escapes. Over immense stretches of time, this radiation carries away energy, and the black hole slowly evaporates, shrinking until it finally disappears. If the information is encoded in the Hawking radiation, then the room inside the black hole is temporary, a space that exists only as long as the black hole does, and when the black hole finally evaporates, the room dissolves, releasing its contents back into the universe in a scrambled, transformed form. Perhaps the room inside the black hole is not one room but many, a branching structure where each infalling particle opens a new chamber, a new timeline, a new version of the story. Perhaps the singularity is not a single point but a fractal structure, infinitely complex, where the rules of spacetime fragment into possibilities we have no framework to describe. Perhaps the black hole is a library, a seed, a doorway, a hologram, and a tomb all at once, and the room inside holds all of these identities without contradiction, because contradiction is only a problem for minds that expect the universe to be simple. We do not know, we may never know. But the whisper of other rooms, the suggestion that the black hole is not an ending but a transition, remains one of the most compelling mysteries in all of physics. It reminds us that the universe is not obligated to make sense in the ways we expect, that the room inside the black hole might be stranger and richer than any description we can offer, and that some doors, once opened, lead to places we cannot imagine from this side of the threshold. If nothing escapes from inside a black hole, if the event horizon is a boundary that allows passage in only one direction, then where does the story of the infalling matter go? What happens to the history, the identity, the information carried by the particles and fields that cross the threshold and spiral toward the singularity? In the ordinary universe, stories are preserved through interaction. Light reflects off surfaces, carrying images. Sound waves propagate through air, carrying voices. Particles collide and scatter, leaving traces that can be measured and reconstructed. But inside the event horizon, the usual channels of communication are closed. The story continues, but it can no longer be told to the outside world. And yet the black hole is not entirely silent. It speaks, but it speaks in a language written on its surface, encoded in the subtle geometry of the event horizon. When an object falls into a black hole, the black hole changes. Its mass increases, its event horizon grows, and if the infalling matter carried electric charge or angular momentum, those properties are absorbed as well, altering the black hole's charge and spin. These changes are not hidden. They are visible from the outside, measurable by the way the black hole's gravity and electromagnetic field shift in response. The black hole remembers what fell into it, but only in the most abstract sense. It remembers the total mass, the total charge, the total spin, but it forgets the details. It forgets whether the infalling matter was a star or a cloud of gas, whether it was hot or cold, whether it carried the light of 1 billion years or the silence of the void. This is sometimes summarized by the phrase, "black holes have no hair," a playful but precise way of saying that black holes are characterized by only a few numbers. They have mass, charge, and spin, and nothing else. All the complexity, all the texture, all the individual characteristics of the matter that formed them or fell into them, all of that is erased, smoothed away, leaving behind only a featureless object defined by 3 parameters. The event horizon is perfectly smooth, perfectly symmetric, a surface that gives no hint of the chaos that might churn inside. It is a mask, a veil, a surface that hides everything behind a facade of simplicity. But perhaps the horizon is not as featureless as it seems. Perhaps it carries information in patterns too subtle for us to detect, in quantum correlations that exist at scales smaller than any instrument we have built. Perhaps the horizon is like a still pond that looks smooth from a distance, but when examined closely, reveals ripples and eddies and tiny disturbances that encode the history of every stone that was thrown into it. Perhaps the room inside the black hole keeps a ledger, and the ledger is written not in the volume of the room, but in the texture of its walls, in the quantum states of the particles that make up the event horizon, in the entanglement patterns that link the inside to the outside in ways we are only beginning to understand. This is part of what makes the black hole such a fertile ground for theoretical exploration. It sits at the intersection of general relativity, which describes gravity and spacetime, and quantum mechanics, which describes the behavior of particles and fields. These 2 theories have been the pillars of modern physics for a century, but they do not fit together easily. General relativity treats spacetime as smooth and continuous, while quantum mechanics insists that everything, even spacetime, must have a grainy, probabilistic structure at small scales. The black hole is the place where these 2 frameworks collide, where the smooth curvature of the event horizon meets the quantum fuzziness of particles and fields, and the collision produces puzzles that neither theory can solve alone. One of these puzzles is the firewall paradox. If information is preserved, if the quantum state of the infalling matter is somehow encoded on the horizon or released in the Hawking radiation, then the event horizon might not be the smooth, uneventful boundary that general relativity predicts. It might be a place of intense quantum activity, a wall of energy so fierce that anything crossing it would be incinerated instantly. This contradicts the prediction that a traveler falling through the horizon would feel nothing unusual, at least not at first. The firewall paradox suggests that the room inside the black hole might have a threshold that burns, a doorway that destroys, and the resolution of this paradox might require a complete rethinking of how spacetime and quantum mechanics fit together. Another thread that cannot break is the thread of causality. Inside the event horizon, the singularity is in the future of every event, an unavoidable destination that every path leads to. But the singularity is also a place where the curvature of spacetime becomes infinite, where the equations of general relativity break down and produce nonsensical results. It is a place where the usual rules of cause and effect of time and space cease to apply, and yet the singularity is not optional. It is written into the geometry, an inevitable consequence of the collapse, and every story that begins with crossing the event horizon ends at the singularity, whether or not the story makes sense when it gets there. Perhaps the singularity is not a physical place, but a sign that our theories are incomplete, a marker that says here be dragons. Beyond this point, the map is wrong. Perhaps the room inside the black hole does not actually contain a singularity, but instead contains something else, some quantum structure, some foam of spacetime fluctuations, some region where the geometry is so complex that it cannot be described by the smooth language of general relativity. Perhaps the singularity is a placeholder, a confession of ignorance, and the true nature of the room's center is something we will not understand until we have a theory that unites gravity and quantum mechanics into a single coherent framework. But even without that theory, we can say this: the black hole keeps its secrets, but it does not keep them carelessly. It encodes them, preserves them, locks them away in structures and patterns that might one day be decoded. The threads that connect the inside to the outside are not broken. They are transformed, hidden, woven into the fabric of the event horizon in ways we have not yet learned to read. The room inside the black hole is not a place of erasure. It is a place of transformation, where information is not lost but is translated into a language we do not yet speak. And so we stand at the threshold, looking inward, trying to read the surface of the horizon, trying to understand what it remembers and what it forgets. The black hole does not answer our questions directly. It does not offer explanations, but it offers clues, hints, patterns in the way it absorbs and emits, in the way it curves space and bends time, and those clues are enough to keep us searching, to keep us wondering, to keep us believing that the threads, however tangled, however hidden, remain intact, waiting for us to learn how to follow them. Light, in the ordinary universe, travels in straight lines. It moves at a constant speed, crosses vast distances without deviation, and arrives at its destination unchanged except for the slow dimming of inverse square law and the redshift of expansion. Light is the messenger of the cosmos, the carrier of information, the medium through which we see stars and galaxies and the distant edges of the observable universe. But near a black hole, light begins to behave differently. It curves, it slows, it spirals. And in the region just outside the event horizon, light does something almost musical. It listens. Imagine a photon, a particle of light emitted from a distant star. It travels through the void, unimpeded, until it passes near a black hole. The black hole's gravity bends the photon's path, curving it around the mass, and the photon skims past, deflected but not captured, continuing its journey in a new direction. This is gravitational lensing, the way massive objects bend the light of objects behind them, and it is one of the ways we detect black holes even though they emit no light themselves. We see the light of background galaxies stretched and distorted into arcs and rings, Einstein rings, where the symmetry of the black hole's gravity creates perfect circles of light around its dark center. But if the photon passes closer, if its trajectory takes it nearer to the event horizon, the bending becomes more extreme. At a certain radius, about 1.5 times the radius of the event horizon for a non-rotating black hole, there exists a region called the photon sphere. In this thin shell of space, light can orbit the black hole, circling it in closed loops, neither falling in nor escaping out. These are unstable orbits. The slightest perturbation will send the photon spiraling inward or shooting outward, but for as long as the orbit lasts, the photon is trapped, circling the black hole like a memory that cannot leave, like an echo that repeats without fading. The photon sphere is not a physical structure. It is a consequence of geometry, a region where the curvature of spacetime is precisely balanced to allow light to loop back on itself. If you could stand at the photon sphere and look outward, you would see the universe distorted into strange and beautiful patterns, stars compressed into narrow bands, galaxies smeared across the sky. And if you looked inward, you would see the back of your own head, the light that left you traveling around the black hole and returning to your eyes. The photon sphere is a place where light learns to listen, where it circles back on itself, where the distinction between sending and receiving collapses into a loop. Inside the event horizon, the behavior of light becomes even stranger. Light can no longer move outward. Even if it is aimed directly away from the singularity, the curvature of space is so extreme that outward has ceased to be a direction. Light can only move inward, or at best, tangentially, circling the interior of the event horizon in trajectories that spiral ever closer to the center. The room inside the black hole is filled with light that has no exit, photons that arrived from outside and are now trapped, circling, falling, echoing through the curved space like sound in a cathedral. This trapped light carries with it the images of everything that fell into the black hole before it. In principle, if you could survive the tidal forces and the heat, if you could hover somehow inside the event horizon without falling toward the singularity, you might see a kind of gallery of ghosts, the light from past events looping and spiraling around you, a visual record of the black hole's history encoded in the photons that have not yet been absorbed. Of course, you could not hover. The geometry does not allow it. You are falling and the light is falling with you, and the images you see would be stretched and redshifted and distorted by the motion and the curvature. But the idea persists, the idea that the room inside the black hole is not dark but is filled with light, a light that has lost its way, that can no longer escape, that echoes endlessly in a space that offers no reflection. There is also light that the black hole creates or seems to create. Hawking radiation, the quantum emission predicted by Stephen Hawking, arises from the strange behavior of particle pairs near the event horizon. In the quantum vacuum, pairs of particles and antiparticles constantly appear and annihilate, flickering in and out of existence in a dance that usually sums to nothing. But near the event horizon, one particle of the pair can fall into the black hole while the other escapes, and the escaping particle carries away energy, appearing to an outside observer as radiation emitted by the black hole. This radiation is not light in the traditional sense. It is mostly low-energy particles, photons in the microwave and radio range, so faint that it has never been detected from any real black hole. But it is there, a whisper of emission, a signal that the black hole is not perfectly black, that it glows faintly in the quantum darkness. The Hawking radiation carries information, or at least it might. As the black hole evaporates, losing mass to the radiation, it should, in principle, release the information it has absorbed, encoded in the correlations between the emitted particles. But the encoding is so scrambled, so complex, that extracting the original information might be impossible in practice, even if it is possible in principle. The light that escapes from the black hole does not tell a clear story. It hums, it murmurs, it carries fragments and hints, but it does not narrate. The room inside keeps its secrets even as it slowly gives up its substance. And so we observe the black hole through the light that surrounds it, the light that bends and circles and spirals, the light that lingers at the edge and cannot decide whether to fall or flee. We cannot see inside the event horizon, but we can see the way light behaves near it, and in that behavior we read the shape of the invisible, the geometry of the room we cannot enter. Light is our only messenger, and near a black hole the message is strange, distorted, looped, but it is still a message. It tells us that the room is there, that it is real, that it curves space and time in ways we can measure even if we cannot visit. Perhaps light, in its way, understands the black hole better than we do. It follows the geodesics, the natural paths through curved spacetime, without resistance or hesitation. It does not fear the event horizon. It does not mourn its capture. It simply moves, tracing the geometry, obeying the rules, and in its motion it writes a diagram of the room's architecture, a map drawn in trajectories and redshifts and lensing patterns. We stand outside and watch the light, and the light, in its circling and spiraling, listens to the black hole, learns its shape, and carries that shape back to us in the only language it knows. To imagine walking inside a black hole is to imagine walking into a space where the rules have changed so completely that the very act of walking loses its meaning. There is no ground to stand on, no air to breathe, no stable reference frame from which to observe the room. But if we set aside the physics that would destroy us, if we grant ourselves the impossible gift of survival and awareness, we can ask, what would it feel like to be inside? You cross the event horizon without ceremony. There is no barrier, no jolt, no flash of light. One moment you are outside, falling toward the darkness, and the next moment you are inside, and the difference is not in what you feel, but in what has become possible. Behind you, the universe you left continues to shine, but the light from it is compressed, blue-shifted into a narrow ring that encircles the direction you came from. The stars are all behind you now, gathered into a shrinking circle, and ahead, in every other direction, there is only darkness, the darkness of the room's interior, the space that absorbs light and offers nothing back. As you fall deeper, the tidal forces begin to make themselves known. Your feet, closer to the singularity, are pulled more strongly than your head, and you begin to stretch. At first, the stretching is subtle, a tension in your limbs, a sense that your body is being gently elongated. But the forces grow, and the stretch becomes a pull, and the pull becomes a tear, and eventually, the structure of your body, the molecular bonds that hold your cells together, the atomic forces that define your shape, begin to fail. This is the descent into spaghettification, the process by which the tidal gradient overwhelms the integrity of matter. It is not a slow dissolution. It is a rapid, violent elongation, a transformation from a three-dimensional object into a thin, one-dimensional stream of particles stretched along the radial direction toward the singularity. But before that final dissolution, there is a window, a brief span of time where you are still intact, still aware, still able to observe the room around you. The darkness is not uniform. It is textured by the light that fell in before you, photons spiraling through the interior, redshifted and distorted but still present. You might see flickers, ghosts, echoes of the stars and galaxies that crossed the horizon in the past, their images trapped and looping through the curved space. The room is not empty. It is full of light that has lost its way, and in that light you see the history of everything that came before you, compressed and overlapping, a visual palimpsest where past and present blur together. Time, from your perspective, continues to pass. You do not feel frozen. You do not experience the time dilation that outside observers see. For you, the moments tick forward with the same regularity they always have, and the singularity approaches not as a distant possibility, but as an imminent future, a moment you will reach in seconds or minutes, depending on the mass of the black hole. The singularity is not a place in space. It is a moment in your timeline, an event that will happen to you, and as you fall, you are moving through time as much as through space, drawn toward that moment by the geometry that has already decided your trajectory. There is a weight to this inevitability, but it is not a crushing weight. It is more like the weight of knowing that the sun will rise, that the tide will turn, that the future will arrive whether or not you are ready for it. Inside the event horizon, there is no suspense, no uncertainty, no branching paths. There is only the path you are on, the path that leads to the singularity, and the room does not offer you a choice. It offers you a journey, and the journey has one destination. Some imagine that the singularity, when you reach it, is a point of infinite density and infinite pain, a place where you are crushed out of existence in an instant. But the mathematics that describes the singularity also confesses its own inadequacy. The equations produce infinities, and infinities are usually a sign that the model has broken down, that the theory is describing something it was not designed to describe. Perhaps the singularity is not a point at all but a region, a quantum foam, a place where space-time itself dissolves into something more fundamental, something the equations of general relativity cannot capture. Perhaps the moment you reach the singularity, you do not cease to exist, but instead transition into a state we have no words for, a state where the usual concepts of space and time and matter no longer apply. Or perhaps the singularity is exactly what the equations say it is, a point of infinite curvature, and reaching it is the end, the final dissolution, the place where your story stops. Either way, the journey ends there, in the center of the room, at the place where all the infalling paths converge, and the room closes around you like a book that has reached its final page. But the journey is not without its own strange beauty. To fall through the event horizon is to experience the universe in a way that no one outside ever can. It is to see the stars compressed into a ring of light, to watch the geometry of space curve so sharply that directions lose their meaning, to move through a room where time and space trade places and the future is written in the floor. It is to be part of a process so extreme, so far outside the realm of ordinary experience that it feels almost mythic, a descent into a space that is both physical and metaphorical, a room that is both a place and a state of being. If we could walk inside, if we could survive the forces and observe the room with clear eyes, we would see something that no telescope or equation can fully capture. We would see the room as it is, not as a model or a theory, but as a lived experience, a space that exists in its own right, indifferent to our understanding, patient in its geometry, waiting for us to arrive and bear witness to its architecture. But the room does not wait for visitors. It simply is, and the traveler who crosses the threshold becomes part of it, absorbed into the structure, woven into the fabric of the black hole's story, and the room continues unchanged, ready for the next arrival, the next falling star, the next moment of inevitable descent. We return now to the sky, to the visible universe, to the stars that burn and the galaxies that drift, and the vast stretches of space where light still travels freely in time, still flows in the direction we are accustomed to. We have walked in imagination through the room inside the black hole, traced its edges, felt the pull of its gravity, watched the light spiral and the stars compress into rings. We have stood at the event horizon and peered inward, and though we cannot cross the threshold and return, we have learned something about the shape of the room, the geometry of its walls, the quiet inevitability of its architecture. The black hole is not a void. It is not an absence. It is a room, a space carved out of the fabric of reality by forces so extreme that they bend the rules we thought were fixed. It is a place where time slows and stretches and transforms into something that feels like space, where gravity arranges every path toward a single center, where light circles and falls and cannot escape, where information might be preserved or lost or encoded in patterns we have not yet learned to read. It is a room that exists whether or not we visit it, whether or not we understand it, whether or not we ever find a way to map its interior. And yet, for all its strangeness, the black hole is not separate from the universe. It is woven into the structure of space-time, connected by gravity to everything around it, shaped by the stars that collapse to form it, fed by the matter that falls into it, and linked perhaps to other regions, other rooms, other universes that we cannot see from here. The event horizon is a boundary, but it is not a wall. It is a threshold, a place where one kind of space gives way to another, where the story of the outside universe pauses and the story of the inside begins. And though the two stories cannot be reconciled, cannot be merged into a single narrative that makes sense from both perspectives, they are both real, both complete, both part of the larger tapestry of reality. Perhaps the room inside the black hole is not a prison but a promise, a reminder that the universe is deeper and stranger than we have yet discovered, that there are spaces we cannot visit and questions we cannot answer and mysteries that will outlast us. Perhaps the black hole is a kind of horizon in a larger sense, not just a boundary in space but a boundary in knowledge, a place where our theories end and the unknown begins. And perhaps that is not a failure but a gift, an invitation to keep wondering, to keep exploring, to keep imagining what lies beyond the edges of the map. The room is there. The door is open. And though we may never walk through it, though we may never return from the threshold to tell the full story, the act of imagining the room, of tracing its geometry and equations and metaphors, of standing at the edge and looking inward is itself a kind of journey. It is the journey of curiosity, the willingness to follow a question into the dark and trust that the act of asking is enough, that the mystery does not need to be solved to be meaningful. The black hole does not offer us easy answers. It offers us a room, a space, a geometry, and the challenge to understand it on its own terms. And in that challenge, in the effort to imagine what cannot be seen, to calculate what cannot be measured, to wonder about the places we cannot go. We find something essential about what it means to be curious, to be human, to stand on the edge of the known and peer into the unknown with a mixture of awe and humility. If you've journeyed this far into the dark with us, stay a little longer. Let the mystery linger, and let it remind you that some doors are meant to stay open, not to invite us through, but to show us that the universe is larger than our maps, stranger than our equations, and more patient than our questions.